A very good morning to one all present here. My name is Neeraj, and today we would be discussing on agriculture demand side management and specifically how we can make. Yes, yes. Am I audible?
Yes, yes, you're audible.
Hello.
Yes, yes, you're audible, Neeraj.
Okay, cool, cool, cool. All right. So today we are discussing on solar pumps and water conservation techniques in the agriculture sector and what different states are doing. That's very important because see both we all know what are the basic needs and what percentage of water do we have and what percentage is being consumed in agriculture sector and a lot of such things we already know, but there is also few areas on which the states are directly working. Let me give you an example. For an example, let's say we are stated in Punjab, so let's talk about Punjab. All right. So in 2021, Punjab government paid PSPCL somewhat around 8,000 crores for free electricity to the farmers. Right? So we usually say that the electricity for farmers is free, and government is providing that. It isn't directly true. PSPCL is providing the free electricity to the farmers. On the other hand, Punjab government or the government pays the same amount to PSPCL. Okay, PSPCL is the discom, the utility body which provides electricity. All right. So now what the agenda of the government is? It's really difficult to now to ask the farmers to pay the amount for the electricity. No wonder farmers are anyway are in a crisis of money. So the only option left for them is that they transit this energy. Okay. So let's say if the farmers are consuming somewhat around 8,000 crore, and with time the demand is increasing because they require to deepen their bore wells as well. They require more pumps, and so that's why no wonder the landscape area is being reducing in Punjab. But yes, the water level is also being dropping down. So that's why the bore well size that needs to be increased. All right. So with time, the demand is also increasing. So that's why the bigger picture, if we take the bigger picture, the government want to transit this energy to the solar energy. Okay. So that's why the solar pumps came into picture, and the government is providing subsidies on these solar pumps. So today we'll be talking about each and every aspect, and we'd also talk about that what different states are doing and what other aspects could be captured into the agriculture demand side. So one is the Agriculture Demand Side Management Program. It is initiated by Bureau of Energy Efficiency. Bureau of Energy Efficiency is a body under Ministry of Power, and it was initiated during the 11th plan. And approximately 19 million pump sets are already in operation, and in fact, the number has increased further. These are some of the older data. Now it is somewhat around 21 million pumps. And what are they? How they are estimating the energy savings potential? They have two ways to do that. One is to switch the older pumps to energy efficient pumps. Now if any day, if you get some time, make sure you visit some Punjab villages in Punjab or Haryana or nearby. You would find that the pumps, or specifically the submersible pumps, those are probably 15 years old, 20 years old, or in fact 25 years old. Many pumps were 20, 30 years old. So the target of the government is to switch these pumps to the energy efficient pumps. So overall cost the government is to pay to the. One thing is that. Second thing is they are also provide subsidies to the farmers on the solar pumps. Okay. We would also talk about the issues farmers are facing with these solar pumps. We will talk about that as well. Then efficiency upgradation of agriculture pump sets, we've talked about that. And then 2.5 lakh new pump sets are being added every year as per the Agriculture Demand Side Management Program. And then 70% of electricity consumption in 8 agriculture intensive states has already been covered. So in the 12th plan, the approach for achieving sustainable energy is they are providing subsidies for energy efficient pump sets. Apart from that, there is also another way of implementing energy efficiency. How they are doing it? For an example, some states through the discoms have mandated that the farmers must have to go for minimum 4-star pump sets or minimum 3-star pump set. That's depending on different states. See, if logically, for an example, if I am the discom, okay, and मैं बिजली प्रोवाइड कर रहा हूँ सभी फार्मर्स को, ओके, लेट्स से आई एम द डिस्कॉम एंड आई एम प्रोवाइडिंग इलेक्ट्रिसिटी टू ऑल द फार्मर्स. अब मेरे लिए ये चीज फायदे का ऑप्शन नहीं है इफ आई एम प्रोवाइडिंग, इफ आई वुड आस्क फार्मर्स कि आप बिजली कम यूज करो, बिकॉज दैट वुड reduce my revenues, right? So just in the same manner, if I would ask the farmers to use energy efficient pumps, it would reduce my revenues as if I am the discom. So yet government has mandated, or government through the discoms have mandated for the farmers that they must have to go for minimum 4-star pumps. Apart from that, solar pumps are also, they are also providing subsidies on the solar pumps. No wonder that would reduce the revenue to the discom, but anyway, it would somehow save the total aspect of total money for the nation. Okay, and then finally, they are also working on the capacity building of all the stakeholders. Capacity building basically means they are awareing the farmers, and awareness program for farmers are being done, so that they could get to know that, okay, the awareness program also includes, yes, any question? The awareness program also include, you know, what kind of crop they have to go for and how much water they could use and irrigation techniques and kind of that stuff goes into the awareness programs. And then finally, the demonstration projects in rural drinking water pumping systems, in which they do some demonstration projects that, okay, these are some of the demo projects in which the state has to work. So let's start with this more introductory video, and then we'll talk about each and every aspect. And let me know if it's not audible.
भारत मुख्य रूप
I'm
से
assuming it is.
कृषि प्रधान देश है और इसकी अर्थव्यवस्था प्रमुख तौर से कृषि पर निर्भर करती है। भारत की लगभग 70% जनसंख्या ग्रामीण क्षेत्रों में रहती है। किसान कृषि की सिंचाई के लिए पंप सेट्स पर निर्भर होते हैं। कृषि उपभोक्ताओं के लिए सब्सिडाइज्ड या मुफ्त बिजली की दरें होने के बावजूद ऊर्जा की बचत करने वाले पंप्स की जरूरत कम नहीं होती। इसी कारण इस क्षेत्र में डिमांड साइड मैनेजमेंट को लागू करने की जरूरत है। एनर्जी एफिशिएंसी सर्विसेज लिमिटेड भारत सरकार विद्युत मंत्रालय के सार्वजनिक क्षेत्र के उपक्रमों की संयुक्त उद्यम कंपनी है एवं दक्षिण एशिया में पहली सरकारी स्वामित्व की एस्को कंपनी है और ऊर्जा बचत के प्रोजेक्ट्स के क्रियान्वयन के लिए विश्व में कुछ कंपनियों में से एक है। EESL ने DSN गतिविधियों को अपनाकर ऊर्जा की बचत करने वाली योजनाओं जैसे घरेलू बल्ब, स्ट्रीट लाइट्स, इमारतें और कृषि पंप सेट्स बिजली की मांग और आपूर्ति के बीच के अंतर को कम कर रही है। केंद्रीय विद्युत प्राधिकरण की रिपोर्ट के अनुसार यह अनुमान है कि वर्ष 2015-16 में भारत का कृषि क्षेत्र अंदाजन 173.2 बिलियन बिजली की खपत करेगा, जो भारत की कुल बिजली खपत का 18.45% है। कृषि क्षेत्र में लगभग 21 मिलियन पंप सेट्स लगे हैं। इस समय कृषि उपभोक्ताओं के लिए शून्य या ना के बराबर बिजली दरें हैं। कृषि क्षेत्र में बिजली की बचत राज्य सरकारों पर सब्सिडी के बोझ को कम करेगी। कृषि क्षेत्र में ऊर्जा की खपत को कम करने के लिए EESL ने भारत में कृषि प्रोजेक्ट्स की शुरुआत की है। इसमें पुराने पंप सेट बिजली की बचत करने वाले BEE स्टार रेटिंग वाले पंप सेट से बदले जाते हैं। EESL ने कर्नाटक में सफलतापूर्वक कृषि DSM प्रोजेक्ट पूरे किए हैं और आंध्र प्रदेश में भी प्रोजेक्ट कार्य चल रहा है। किसानों और डिस्कॉम दोनों ने नए पंप सेट्स की कार्य कुशलता के लिए संतुष्टि और खुशी जाहिर की है। कुल मिलाकर औसतन 35% ऊर्जा की बचत की है। प्रोजेक्ट के क्षेत्रों में EESL द्वारा ऊर्जा की किफायत करने वाले पंप सेट्स के बारे में किसानों को शिक्षित करने के लिए कार्यशालाएं तथा जागरूकता अभियान चलाए जाते हैं। EESL टीम प्रोजेक्ट गांवों में घर घर जाकर प्रोजेक्ट का प्रचार करती है और प्रोजेक्ट के लाभ किसानों को समझाती है। गांव स्तर पर कार्यशालाएं आयोजित करके किसानों की शंकाएं दूर की जाती हैं। प्रोजेक्ट्स के क्रियान्वयन के लिए विभिन्न प्रकार के पंप्स तथा पैनल्स का भंडारण किया जाता है। ऊर्जा की बचत करने वाले पंप सेट्स की मरम्मत और रखरखाव। पुराने पंप सेट्स एवं पैनल के बदले में किसानों को ऊर्जा की बचत करने वाले पंप सेट्स और बिजली के पैनल मुफ्त में प्रदान किए जाते हैं। लाभार्थियों को प्रोजेक्ट की अवधि में निश्चित समय के लिए मरम्मत और रखरखाव की सुविधा मुफ्त में दी जाती है। पुराने पंप को हटाने की प्रक्रिया यह सुनिश्चित करने के लिए कि पुराना अकुशल पंप अन्य कहीं भी इस्तेमाल नहीं किया जा सके, कुछ निश्चित अवधि के बाद पंप और मोटर दोनों में छेद करके पुराने पंप्स को निष्क्रिय किया जाता है। ईईएसएल की दूरदर्शिता। भारत में कृषि डीएसएम प्रोजेक्ट्स के क्रियान्वयन के द्वारा ईईएसएल का
Right. So the basic agenda is pretty straightforward, and that's what it is कि जो फ्री इलेक्ट्रिसिटी दी जा रही है फार्मर्स को, वो या तो फ्री रेट्स पर ही है या फिर बहुत कम रेट्स पर इलेक्ट्रिसिटी दी जा रही है. सो द cost that the farmers are paying is really negligible. So the subsidized rate on which the electricity is being given, the agenda is to further invest into the agriculture sector in either in the solar pumps or through the energy efficient pumps, so that that subsidized electricity could have been reduced. So that cost that the government is paying for the farmers for subsidized electricity could be reduced. Okay, so for an example, the government has paid 8,000 crores for the farmers in Punjab. So the next year, by switching these pumps to the solar pumps, they may have to pay somewhat around 7,500 crores. That's what the agenda is. Reduce their overall cost through these agriculture demand side management initiatives. Now, different states have taken different initiatives under the agriculture demand side management program. For an example, Haryana has mandated the use of efficient pump sets. Now, how they are mandating it? Okay, so any new connection for the pumps. For an example, if I am a farmer and I have my land somewhere nearby, let's say Ropar or Patiala, if I have to use a pump, I have to apply for an electricity connection. Okay, so whenever I'll apply for an electricity connection for my pump set, they will mandate me. They mean the utility or the discom will mandate me to have minimum 4-star energy, 4-star pump or minimum 3-star pump whatsoever, depending on the state laws, depending on the notification, that if they have mandated 4-star or 5-star or whatsoever. Second is Haryana is also providing through their state designated agency, which is Hareda. They are providing financial assistance for adoption of energy efficient pump sets. Similarly, Punjab is also providing mandatory use of efficient pump sets, which has also been done by PSPCL, and apart from that, notification by PSERC for implementation of AGDSM activity. Similarly, Rajasthan is also providing financial incentives for adoption of efficient pump sets. Chhattisgarh, it is providing rebate in electricity bills for adoption of energy efficient pump sets if somebody applies that. Similarly, Karnataka again mandated the use of efficient pump sets, and Gujarat, Discom is in the process of implementing AGDSM as per the DSM regulations. So logically, if you see those states which have an agrarian economy, they must have to take the action. Similarly, for example, Haryana, Punjab, they both are agrarian economy. So does Rajasthan also have a lot of agriculture part as well. So every state those have a huge economical part from the agriculture. So those state has to work on it. And see, whenever we talk about energy, it's not only electrical energy we talk about. There is also other sources of energy which are being consumed in the state. For an example, um, apart from electricity, CNG is also being consumed. Apart from that, natural gas is also being consumed. Petrol is being consumed. Diesel is being consumed, and some other sources of energies are also being consumed. Pet coke is being there. Vitamin is there. Aviation turbine fuel is there, and high speed diesel, low speed diesel, and a lot of things are there which are being consumed within the state. And everything is a source of energy. So now, when people consume these sources, so for example, if a state has an agrarian economy, I'm talking with the aspect of policies. Okay, so for an example, if I am making the policy for a state, now I first have to look at both the aspects. One is the GDP of the state, that how much GDP the state is having, and of that GDP, what percentage is being shared by different sectors. Okay, so for an example, if at today I'll say that okay, Punjab has, yeah, or Haryana has X GDP. Okay, let's say which is somewhat around, let's say 3 lakh crore is the GDP of Haryana. Let's say, let's just assume it. Okay, so out of that 3 lakh crore, different sectors are contributing to what percentage? For an example, how much municipality is contributing, how much buildings are contributing, how much transportation is contributing, how much agriculture is been contributing, how much discom is taking, and other sector if there is any. Okay, so out of all the major 6 sectors which are there, let's say building, transportation, agriculture, municipalities, discom, or industries. Okay, so how much these 6 sectors are contributing to each and to the total GDP of the state. So out of that, if the GDP percentage of a particular sector is low, for an example, let's say for any state, let's say for Delhi, okay, the total percentage or the total percentage in the agriculture sector is very low. Okay, Delhi has very limited agricultural land. Similarly for Chandigarh, okay, very limited agriculture land. So yet in that case, my first goal would be that the energy consumption of that area should be reduced as well. Okay, should be minimum as well. All right, so that's how we take things. And apart from that, it never means that okay, if the state has agrarian economy, it means that only that sector would consume a higher energy. For an example, if I talk about Punjab or Haryana, we say that okay, agriculture sector has, it is the agrarian economy, and agriculture sector would consume a higher energy. Let's say maximum would be under industries, and then maybe agriculture or industries, or maybe buildings. Okay, and then the third would be agriculture, or maybe the second would be agriculture. So let's say if second is agriculture, it does not mean only agriculture would be the one which is having the maximum energy. There are several sectors which depend on the agriculture. Okay, for an example, there are several industries which are food based industries. Okay, and which basically depends on the crop generation by the agriculture sector. Apart from that, there is another service sector which is the transportation sector. Most of the transportation in Punjab majorly runs on the agriculture sector. Okay, so for an example, if for 1 year there is a reduction in the total crop output of the agriculture sector in Punjab, you would definitely find the overall reduction in the energy consumed in the transportation sector. So does the reduction in the industrial sector. Okay, so the overall GDP does not mean that does not mean that we only have to look at the GDP. It means we have to look at the subsectors. And in that, if I'm looking at the agriculture sector, it does not mean that I'll take very intensive action to reduce the energy consumption in the agriculture sector. I also have to look at the rest of the sector, because every action I take on the agriculture sector would have consequence on both other sectors, transportation and industries. So that's why state, whenever they make policy, they have to look onto each and every aspect about the GDP of the particular sector, and how much it would impact on the other sectors, let's say transportation, or another one which we talk about, let's say industries. Okay, so that's why whenever you in future, or probably you look at a policy, always think about other aspects as well, that okay, yes, if state is coming up with any policy, it's never being made in a day. Since it's last year I was preparing the action plan for Punjab, and it's been more than a year, and it yet hasn't been prepared. We are yet making it, so it may takes more than 6 months from today. So it takes more than 2 year or 1.5 year to make one specific policy for a state, or one small plan for a state. So it involves a lot of studies. So does, because it requires the aspect or analysis of each and every sector. All right. So now this is the basic analysis of pump set efficiency potential, that okay, how much efficiency potential does one pump set could have. So the total electricity consumption in India, which is somewhat around 950 billion units, and energy consumption in the agriculture sector, which is somewhat around 18%, 171 billion units. Now, what is the average installed capacity? It's somewhat around 7.5 kilowatt. This is the average. Many farmers may have 15 HP pump, 5 HP pump, 10 HP pump, 25 HP pump, 30 HP pumps. All right. And annual operating hours is somewhat around 1800. And total number of pump set is around 20.27 million pumps. So the total annual average annual consumption per pump is a kilowatt hour per pump, which is somewhat around 13,500. And then we are talking about average saving potential per pump, which is somewhat around 25%. So 13,500, 25% of which is somewhat around 3375 kilowatt hour per pump. And then we multiply the same with 20.27 million pumps, and then we get the total energy savings of 68.41 billion. units per year, and then we take, let's say, 5 rupees per unit, because for farmers we have a very reduced cost of electricity. So 307.85 billion rupees of energy savings could be achieved by replacing these pumps or by having the energy efficient pumps. We are not transiting these pumps to solar pumps. We are just saying that by having these pumps energy efficient, and then overall cost would be somewhat around 45,000 rupees per pump, and then the total investment required would be 912.15 billion rupees, and within 3 years we may have our a simple payback, and this may avoid somewhat around 10,000 megawatt of generation capacity. So no wonder. There is one more thing which is very specific and very there are many claims for the same. uh, Now you may say that okay, it's a democratic country, and these things may happen or may not happen. So uh, I'm not let's not talk about political aspect of it, but let us just talk about the policy aspect of the same. Okay, long back when Punjab started free electricity, at that time the average pump set those the farmers were using were somewhat in a range of 5 HP. Okay. 5 HP, maximum 7.5 HP. This was the groundwater level. Okay. Unfortunately, with there are many claims which says that due to the free electricity being provided to the farmers, they are running more pumps now. Okay, the pump has been, they just turn the pump on and then they leave to their home, and then when the electricity turns off, the pump goes off accordingly. Okay, they do not come back to the field to turn the pump off. This is very specific statement by many newspapers, which is a direct claim, which says that due to the free electricity, when they provided the free electricity, the average pump power was somewhat around 5 HP or 7.5 HP. Today, the status is that most of the farmers are using, the average has further increased because they have consumed so much of water that the groundwater level has been reduced. Okay, so they have to deepen their borewell, and in order to deepen the borewell, they further have to increase the capacity of the pump. And now the same pump are more than 25 HP, 30 HP. Okay, so and they have a direct allegations to against the same statement, that it is because they are providing free electricity to the farmers, and that's why they are overusing the water which is basically required to their fields. So I'm not saying what my opinion is, but that's again, if in future anybody of you would be making the policy, make sure you also read these kind of things in, and you take your own opinion while making those policies. So far, no wonder the state does not have any other option apart from providing free electricity to the farmers. So that's one thing can only be the option. Is the another the only thing the state have an option is to provide awareness program, so that the farmer may use some other drip irrigation or kind of that stuff which may consume less water. So that may be one option the farmer may go for, because no wonder that may be a case where free electricity has further make the farmers to overuse the water which is being required. So no wonder we have 3% of the fresh water with us. And the factors majorly which are increasing the water demand, which is one is the growth of human population, which is anyway India have crossed China as well now. um, the bigger aspect is the standard of living. Okay, which this factor is usually being ignored, but I would say we have to talk about it. Long back by 20, let's say by 1980s 1970s, people have less water at their home. Okay, now with the 24/7 water supply, the initial faucets, if you remember, which used to be at our home, the water supply was very limited, morning 1 hour or evening 1 hour, and we used to fill our utensils from that water, from that water which we get for 1 hour or 2 hour or 3 hours a day. Okay, so those utensils we used to fill, and then we, for the whole day we used to consume that water. Okay, and then the faucets that we used to have at our home, the fixtures that we used to have at our home, they have a specific flow of water. Okay, let us say 3 liters per minute, 4 liters per minute, 6 liters per minute, or whatsoever. Okay, most of the houses did not have the shower jets. Okay, as well. All right, and uh, with time, as the standard of living has increased, we have total flush system at our home. We have shower jets at our home, um, proper faucets at everywhere, in kitchens, in washrooms, and everywhere. Okay. The bigger aspect is the flow of these fixtures has also been increased with time. Okay. We have targeted specifically, for an example, showers. They have a flow of more than 11 liters or 15 liters. Okay, and we always look for showers which provide more water. Okay, and no wonder it's just a momentarily happiness which we need through the showers. So there are some green building aspects as well, which specifically mandates to reduce the flow of the water from these faucets. Okay, there are devices such as aerators, which is very specific device, a low cost device, somewhat around 80 rupees, which would reduce the flow of water from 6 liter to 3 liters, or let us say 12 liter to 3 liters or 4 liters. Usually the flow of water 3 to 4 liters per minute is very okay. Is okay if we talk about the faucets, either it is the kitchen faucet or the washroom faucets. 3 liters per minute is pretty good. Okay, but we usually nowadays also we are using the fixtures which are having a higher flow, so that's not a good thing. So government has come up with in order to have water conservation, they have three basically option: reduce demand, reuse wastewater, and replenish groundwater. So they have come up with Jal Shakti mission, which have its own focus on conserving groundwater. Basically, five water conservation interventions which they have gone for: intensive watershed development, renovation of traditional and water bodies which they are renovating, reuse and recharging of borewell structures, and water conservation and rainwater harvesting, and then intensive afforestation. So these are few aspects on which the Jal Shakti mission is running. Please do not confuse it with the other running missions such as Namami Gange and rest. They are trying to clean the water. This agenda is just to conserve the water. So there are some other running agencies as well, running ministries as well, just to conserve the water and to clean the water. So they have different opinion as well as policies. So the basic water loop and the nutrient loop is being pretty directly being shown. Post domestic use or industrial use, the aspect should be to collect that water, to treat that water, and then treated water to be used again in the either in the flushing or in the agriculture sector. And then through the water sources, the directly water could be used in the domestic type, so that the whole cycle can be continued. The bigger picture, the bigger problem here is, for example, in Chandigarh, most you might have heard that the agriculture sector or the water they use in the buildings is directly the treated water that they get. So I was recently working with the Paryavaran Bhavan, and I looked into their water bills, and then there I get to know that the water they were getting were treated water, basically from their sewage treatment plant. So which is a good thing. UT has worked on. Similarly, if other states may take these kind of initiatives, it may reduce their water uses. I mean, it may help them in reusing the same water. So no wonder agriculture sector, it is dependent on water availability. Another thing is the more use of pesticides and chemical fertilizer, it has caused water pollution. And two things which are majorly required: water harvesting and recharging systems are majorly required. That's in the agriculture sector. So we'll be talking about them today. So what are the goals basically of water conservation, specifically in agriculture sector? One is the state has to ensure the availability of water. Okay, the water should be made available. That the state has to ensure the water security. That this much water, if the agriculture sector requires, they must have to provide that either through the canal system or through the borewell system or whatsoever. But the state has to provide that. Then second is they have to create and maintain the field channels for water delivery, and that's again through the canal system. It has been easy to create and maintain the field channels. Then land leveling, which allows water to be evenly distributed, that is another one thing. And then good water management practices, which may be needed to keep the optimum level of water, and which would maximize the production. Now this is again a point of awareness to the farmers. Most of the farmers in Punjab, specifically, why I'm saying about Punjab, I have done the studies there, and um, I mean, on the agriculture sector, I have been in touch for the agriculture sector with PEDA, and we have been working on the state action plan as well, in which I took some surveys from the farmers as well. So most of the farmers, they used to say that they never switched off the motor any day. The motor is automatically being turned on whenever there is electricity, and automatically being turned off whenever the electricity goes back. So this is very specific aspect, and most of the times the motor being continuously running for 15 hours, 18 hours, and that's again, that's a too much uses of water, which is not basically required. And second thing is double crops the farmers are going for. Initially, they used to have wheat and rice for once a year. Nowadays, they are doing the same thing twice. And not only that, these both of the crops, for example, rice is a very water intensive crop. Uh, the same, yet the Punjab is going for it. What are the tools, implements, and methods for providing water to for water to reach the field? Major is three options. Canal irrigation is one thing, through the canals, and then channels are being prepared for the fields. One thing is that, or through the motors directly being connected to the canals. One thing is that, and whenever the fields require the water is being spread it out in the canals, and then through the canals the water moves to the fields. The second is drip irrigation. Another is also sprinkler irrigation, on which we talk about. And then the surface irrigation, which is through the gravity, in which the whole pipe is going through, and then there are holes in these pipes, basically, or there may be valves being opened. So the water through the gravity flows into the field. Then there is furrow irrigation, which is basically conducted by creating small parallel channels along the field length in the direction of slope. So within the slope, they prepare the channels, and then in those channels, the water is there, and then the water being spread it in the soil, and that's again a very efficient method of irrigation for the crops. And then there is center pivot irrigation, which is basically kind of sprinkler irrigation, and it has several segments of pipe joined together, and which supported by trusses, and then it basically runs within a circle. So it moves and it rotates within a circle, just like the sprinkler you might have seen in the fields. And then finally is irrigation by lateral move. This usually do not happen in India, but yeah, in many countries they are following this. In India, we already have a land scarcity, and farmers do not want to go with these techniques. So, in simple terms, the carry that they make, they do not go with these kind of irrigation techniques. But yeah, this is also in which they have a series of pipes, and then they run the wheels, and the water is being flow from spread it from or sprinkled along its length. So that these are few methods for irrigation which the farmers are already using. Now, apart from these, there are few more tools on which the farmers are using. So one is the reservoir, and another one is dam. So reservoir is basically an artificial place where water is collected. So we'll talk about reservoir again ahead. It does not mean that it is for a whole community. The reservoir is there. Sometimes for a small field also, they prepare a reservoir, and then the dam, we all know what a dam is. So in order to control the flow. And then pumps and motors and irrigation sprinklers. These are the major tools on which one has to talk. So again, let's see with a small video, and then we'll move ahead.
भारत में 83% पानी का प्रयोग कृषि के लिए होता है। जल स्तर में निरंतर गिरावट का मुख्य कारण कृषि में लगातार गेहूं धान फसल चक्र तथा अधिक सिंचाई जल की जरूरत वाली फसल जैसे गन्ना आदि को अपनाना है। ये स्थिति तब और भी भयंकर हो जाती है जब किसान धान की 2 फसल लेते हैं। पिछले कुछ वर्षों में वर्षा की कमी रही है, जिससे भूजल का पुनर्भरण भी कम हो रहा है। जल के संकट के समाधान के लिए ऐसे नियोजन व संचालन की आवश्यकता सामने आई जो उनके अपने प्राकृतिक स्रोतों पर आधारित हो।
1 किलो धान पैदा करने के लिए 3000 लीटर पानी चाहिए। आप देखिए इतना धान हम पैदा कर रहे हैं और इतना पानी हम जमीन से निकाल रहे हैं। अगर धान की सीधी बिजाई के साथ हम स्प्रिंकलर का भी उपयोग करें 50% पानी धान में बचा सकते हैं।
वैज्ञानिकों द्वारा कई कारगर सिफारिशें, यंत्र और तकनीकी अपनाने की सलाह दी गई है, जिसके फलस्वरूप खेती में पानी की काफी बचत की जा सकती है। सरकार इन यंत्रों एवं उपकरणों को खरीदने के लिए विशेष रियायत भी दे रही है। भूमि समतलीकरण किसी न किसी यंत्र के द्वारा हर किसान द्वारा किया जाता रहा है। अधिकांश समतलीकरण प्रभावी नहीं हो पाता है। लेजर द्वारा समतलीकरण की तकनीक में लेजर की किरणों द्वारा समतलीकरण की क्रिया पूर्ण होती है। 1 एकड़ खेत को समतल करने में सामान्यतः 2 घंटे लगते हैं। इस प्रकार भूमि के समतलीकरण से पानी की काफी बचत तथा फसल उत्पादन में वृद्धि होती है।
लेजर लेवलर से हम जमीन का लेवल अपने हिसाब से इस तरह से बना सकते हैं कि जो हमारा सिंचाई का पानी है सही जगह पर सही मात्रा में पानी सप्लाई करने में उसको आसानी होती है।
धान के खेतों में 10% व गेहूं के खेतों में 10 से 20% पानी की बचत की जा सकती है। गेहूं की फसल में पानी की बचत के साथ साथ 10 से 15% अधिक उपज भी मिलती है। धान और गेहूं फसल चक्र की लाभप्रदता दिनों दिन कम होती जा रही है। अधिक आमदनी के लिए किसान भाइयों को अब इस फसल चक्र से निकालकर रबी में गेहूं की जगह तिलहन एवं शरदकालीन मक्का लिया जा सकता है। खरीफ में धान की जगह मक्का तथा दलहनी फसल ली जा सकती है। इसके अलावा फल एवं सब्जियां इत्यादि फसलें भी ली जा सकती हैं। किसान पारंपरिक सिंचाई विधि के बजाय उन्नत सिंचाई विधि जैसे ड्रिप सिंचाई, फव्वारा सिंचाई आदि अपनाकर पानी की काफी बचत कर सकते हैं। ड्रिपर द्वारा पानी बूंद बूंद से पौधों की जड़ों में दिया जाता है।
जहाँ पे बारिश कम होती है, जहाँ पे रेनफेड एरिया है, वहाँ पे हम कोशिश ये करते हैं कि जो वर्षा का पानी है वो किसी तरह से रोक लिया जाए। टपक सिंचाई व्यवस्था हो चाहे फव्वारा सिंचाई व्यवस्था हो, उस तरह से हम सिंचाई की व्यवस्था करें। जो फ्लड सिंचाई हम करते हैं, खेत में ट्यूबवेल चला देते हैं, पानी की बर्बादी होती है, उसको भी हमें रोकना पड़ेगा।
पारंपरिक सतही सिंचाई की तुलना में जल की औसतन 40 से 50% बचत की जा सकती है। वहीं उत्पादन में 20 से 25% तक की वृद्धि की जा सकती है। ड्रिप सिंचाई का एक बड़ा अन्य लाभ ये भी है कि भूमिगत लवणीय पानी और मल जल को कृषि में उपयोग के लिए भी इस पद्धति को अपनाया जा सकता है। कृत्रिम भूजल पुनर्भरण, जहां बूंद गिरे उसे वहीं समेट लो की तर्ज पर एक नारा दिया गया कि खेत का पानी खेत में और गांव का पानी गांव में। भूजल स्तर में गिरावट को रोकने के लिए वर्षा ऋतु में पानी को बहकर नालों में जाने की अपेक्षा भूजल रिचार्ज के लिए प्रयोग करने पर अधिक बल दिया जाना चाहिए।
जो भी ट्यूबवेल है जो कि आजकल अबंडेंट है, चूंकि ग्राउंड वाटर नीचे चला गया जिसकी वजह से वो आजकल काम नहीं हो रहा है। लेकिन अगर उसमें पाइप लगी हुई है तो उसके ऊपर एक हम फिल्टर लगा के और जो भी बरसात का पानी जो एक्सेस होता है उसको उसके थ्रू हम उतार के नीचे उतार देंगे, जिससे उनकी एक तो फसल भी बच जाएगी और जो चोवा है जिसको बोलते हैं जो ग्राउंड वाटर टेबल है वो भी ऊपर आ जाएगा।
पुराने तालाबों की खुदाई एवं नवीनीकरण द्वारा गांव के व्यर्थ बह जाने वाले पानी को भूमि के अंदर भेजा जा सकता है। छत के पानी का भी भूमि में रिचार्ज एक ऐसी पद्धति है जिसे कई राज्य सरकारों ने अनुमोदित किया है। परीक्षणों द्वारा ज्ञात हुआ है कि यदि मीठे पानी की कमी हो तो उस पानी से कुछ सिंचाई करने के पश्चात शेष सिंचाई लवणीय क्षारीय जलों से करने पर अच्छी उपज ली जा सकती है।
खुले में लगाएंगे सब्जियां खारे पानी साथ में तो वो नहीं होगी, वो मर जाएगी। लेकिन अगर पोलिया उसमें लगाते हैं और उसमें ड्रिप से सिंचाई करते हैं और जो खाद है वो भी हम ड्रिप के द्वारा देते हैं, तो उसमें हम इन सब्जियों की पैदावार पोलिया उसमें बहुत अच्छे से प्राप्त कर सकते हैं।
सतही एवं भूमिगत जल निकास के पानी का उपयोग। सतही जल निकास नालियों के पानी की गुणवत्ता कृषि में प्रयोग के लिए उपयुक्त है। इसीलिए सतही नालियों के पानी को किसी भी फसल की सिंचाई के लिए प्रयोग में लाया जा सकता है। मेड़ नाली यानी बेड प्लांटिंग विधि द्वारा अगर फसलें ली जाएं तो इसमें भी 20 से 30% पानी की बचत हो सकती है। पानी के अधिक बहाव एवं वाष्पीकरण को रोकने के लिए ऐसे उचित उपाय करने चाहिए। कई संस्थानों द्वारा इन तकनीकों में समय समय पर सुधार किए जाते हैं। आज ये सोचने का विषय है कि कहीं हम अपनी आने वाली पीढ़ियों को उनके अधिकार से वंचित तो नहीं कर रहे। समय से पानी बचाने के उपाय करें ताकि हमारी आने वाली पीढ़ियां हम पर गर्व कर सकें।
So, just in the same aspect of Jal Shakti Mission, the Punjab government has their own scheme of Pani Bachao Paise Kamao, in which if the farmers are able to save amount of water, they are being directly benefit transfer, the DBT kind of scheme, of funds to their account, in which on the basis of what amount of water they have saved. Similarly, the second thing is the kind of irrigation techniques they are using. For example, sprinkler. Just in the last video also, it's being said that for 1 kg of rice, they require 3,000 liters of water if they are directly using it. On the other hand, if we switch the same to the sprinkler system, we may require somewhere around 1,500 liters of water. So these are some of the aspects from which the farmers are unaware, and so does on the pump sets. In many fields, we found that the pumps they are using are fundamentally oversized. Okay, and that is also one major things in which for which the state may work on, that for particular zones which are not the dark zones, or which have a sufficient water level, the pump capacity should be mandated, that okay, these areas should not have more than 5 HP pumps or 7.5 HP pumps or 10 HP pumps, so that the overuse of water could have been reduced. So today we would also be talking on one aspect of irrigation, which is basically drip irrigation. Major aspect we all know about it, but I'll also talk about what are basic tools and analysis under the drip irrigation. No wonder it is a micro irrigation method, so that a target is to provide water to the roots of every crop, and then the water used, which the water when it is being used drop by drop. So the water used, it is very low, and that is drop by drop the water is being used, and it only irrigates the root zones of the crop. So there are certain analyses by the agriculture department, and this is again see why it is being difficult for the governments to implement is, look at the policy aspect of that as well. One thing is, there are three major departments. Okay, one is the Department of Agriculture and Farmers Welfare. Okay, that is one department which would work for the farmers, for their welfare, and for the agriculture part. Or there may be agriculture university or the agriculture department. Okay, agriculture university may be like Punjab Agriculture University, which may be in the direct contacts of farmers, and similarly other states have their own agriculture university which may have a touch with the farmers, and the major one is the agriculture department. Now, if I want to have water efficiency, or if I want to have water conservation in the state, which department would work for that? The Department for Water Supply and Sanitation. Okay. Now, that's where the challenge comes. These are two different departments, and one department, if it is making the policy, it have to implement the policy through another department. Okay. Similarly, if I want to implement energy efficiency into that, the department which would make the policy is either the center ministry, or if the center ministry or Ministry of Power is not making the policy would be made by, let's say, if we talk about HAREDA, Department of New and Renewable Energy, HAREDA would make the policy. Then it would ask the DISCOM to implement the policy, and then the DISCOM would implement the policy with the help of Department of Agriculture. Okay, so now there are multiple departments which comes up into the picture, and that's why it becomes bit difficult. There is no one department which can handle each and everything, so that's why different departments are required, and that's why it becomes bit difficult for different departments to implement these kind of stuffs, because anybody who is working in the agriculture department may not have enough knowledge about the same subject of water conservation, or may not have enough knowledge about the same subject of solar pumps and all. Okay, though they have the engineers, but that's how during implementation it may become it comes as a challenge. So that's why proper capacity building programs are being done for them as well, and that's why it becomes a bit difficult to implement these kind of programs. But yes, every state has done very well so far in implementing these programs. And you see nowadays also, if you visit any village or field, you may find sprinkler system very frequently being installed in different fields. So in drip irrigation, basically there is just a pipe which is being installed within the slope of the field, and the water flows by capillarity and gravity of the soil, and then the soil moisture content of the crop root zone is maintained at nearly optimum level. So just because the pipe have the water, and then the water is being spread into the roots of the crop, so that's why the water soil moisture level is always being maintained at an optimum level, which is a very efficient aspect of drip irrigation. So here is how the arrangement for the drip irrigation is being drip system is being done. So many people also use a small system for we have shown here a section A. At first you see there is a water course or any water nearby, and through the pump you fill that water into an overhead tank. Okay, so that's in section A. Here is the water to the pump. The pump is pump, which would take the water from here and then fill the overhead tank for with the water. The water source through the pump, and through the pump the overhead tank is being filled. From that overhead tank, a main pipe comes out, which is basically termed as the lateral pipe. Okay, and then there are few more things added, because it is also being said that the fertilizer that you are using and also the filter unit, both things are required. So post filtering the water, it's not a kind of RO filter, it's just a normal filter that they use. And then there is a fertilizer tank as well. It is being mentioned, or it is being said that the fertilizer, instead of spreading that over the crop, better is to spread that fertilizer through the drip irrigation system only. Okay, so the fertilizer also goes to the roots of the crop, so that's why a fertilizer tank is there, which directly being mixed into the water that is being flowing through the lateral pipe. And then through these lateral pipe there are trickle lines as well. These are the trickle lines which are onto the left and the right, the vertical lines basically. And these trickle lines have emitters basically the small holes into these pipes. These trickle lines are also basically the pipes, but of a smaller radius, and these are basically terms as the trickle lines. And then so again I'll repeat the system. There is a water source, then pump, then overhead tank, and then the overhead tank has the main line, and then from that main line a smaller radius line goes to the left and the right, which are the lateral pipe. And then from the lateral pipe there are further smaller radius lines, which are the trickle lines. And in these trickle lines there are emitters, which are smaller holes, and from these smaller holes the water as well as the fertilizer being spreaded into the field. And the major aspect we have already talked about it, that the water flows to the roots of the crops, so that's why it provides more production to the crops. And not only the crops production, it also provides water conservation and reduction in the water uses. Now this is how the commercial drip irrigation system looks like. You may add few more things like non-return valve, and then the main line, air valve, if sometimes if the brush pump sucks water on air along with it, so air valve is also there. And then a complete sand filter and everything, it is being installed. It is a bigger system which is being installed by any agency, and then you have the complete piping system, and then the trickle lines, and then the drip or emitters are there. So that's a complete bigger system of drip irrigation system. Now, for which crops drip irrigation system is useful? For commercial ones, it is useful for sugarcane, cotton, groundnut, and chickpea. Similarly, for vegetable crops, it is being useful for cabbage, cauliflower, okra, tomato, potato, onion, chilies, radish, brinjal, bottle ground, French bean, capsicum, beans, baby corn, carrots, cucumber, bitter gourd, bottle gourd, ash gourd, ghirki, and stuff. And similarly for fruits, banana, grapes, citrus, pomegranate, papaya, pineapple, watermelon, sweet lime, mango. For these crops, the drip irrigation system is useful and is successful so far. These are some of the small scale investment in the drip irrigation system. So many farmers have at their own end or at their own small places, they have tried these kind of systems. This is small bucket basically, or a small overhead tank which they have prepared. No wonder the tank that you are making, it must be at a higher height. Make sure that, so that the water could flow through the gravity, and then through the main lines, they have from the same tank they have prepared a multiple lateral lines below, if you see that. And sorry, hold on a second, please. All right. So this is the small scale investment, and in many countries where there is water scarcity, in Kenya, specifically in the African countries, they have made these kind of small scale irrigation system. No wonder in Rajasthan also I've seen some fields using such kind of systems. So directly the lateral pipes, and then emitters are there in these lateral pipes. So this is also a very specific, and all they require is a bucket which is basically kind of a water reservoir, and simple plastic hoses for distribution. Some at some places you might have seen in the videos in the YouTube, they are also using bamboo as distribution pipes, so which is also a very efficient system. You don't require plastic pipes as well, or the PVC pipes as well. Now all you require is bamboos, and then you make holes in those bamboos, and that also works fine in the fields. And then this is basically for the small scale farmers, and one can build it locally with available materials, and it has high self help compatibility. Somebody may require training in the beginning, but usually no such training is directly being required. And then clogging may be a challenge one may face into in these. Now what somebody would require for that: a 20-liter bucket with 30 meters of hoses which is connected to the tank, and then tank is on the elevation is of at least 3 meter and refill daily. So the tank should be required at a 3 meter height, which is basically somewhat around 10 feet of height. The tank must be at the 10 feet of height, so that the gravitational force could be there. And then water is distributed by gravity, which is true. And then there are buckets fits available, which is in the smallest types of drip irrigation. So that's the only stand here is, which here in the right side, if you see the schematic, the smaller bucket, and then you have a pipe, the main line which is going through, and then you have some main line, or basically the lateral pipes, and then finally you have the trickles, or the trickle lines, and in those trickle lines you have those emitters for the water. So, cost, operation, and maintenance. No wonder the industrial systems are expensive. At first, the bigger systems they are expensive, but yeah, small scale farmer are able to build a self-made drip irrigation system. They are easily able to make that, or and um, No wonder in generally it would be more costlier than the manual irrigation, but it would definitely improve the yield, crop production would be increased, and the water uses could be reduced. And then the operation and maintenance. Oh, three things: one has to check leaks, water leakage, it must be repaired immediately, and pipe should be flushed so that the clogging of water is not there. For an example, in many places, specifically near in Haryana or in Punjab, also in the Mohali region, you may find that the water have a higher level of fluoride into it. So if you're using different kind of pipes, for an example, many people at some places they may use iron pipes, or at some places if they are using PVC pipes as well, the clogging is very common. The clogging of those pipes is very common. So that's another one thing. So the pipes required to be properly flushed once in a month, and leaks need to be repaired immediately. So these are some of the advantages and pros and cons. High water application efficiency, it can irrigate irregular shaped fields. So if the feed level is not uniform, yet it can irrigate that field because the water from the behind it is coming through the gravity. Moisture within the root zone, it can maintain the moisture within the root zone. It would minimize soil erosion and fertilizer loss. It would uniform distribution of water, low pressure operation. So these are some of the pros. And similarly for disadvantages, for the bigger systems, they are expensive. Commercial system require a proper pump. It would require valves, different type of valves as well. It would require a complete fertilizer box as well. So commercial system may be a bit expensive. Similarly, the sun may affect the tubes used for the drip irrigation. Clogging risk is also there for these systems. Drip irrigation for some fertilizers are also there, in which a sprinkler irrigation is required. Only the sprinkler irrigation or more water could activate those kind of fertilizers. So fertilizer also require some particular amount of water. So in many cases, if you are using that kind of fertilizer which require more amount of water, in that case drip irrigation may not be that successful. You require a separate sprinkler system also to activate those fertilizers. So that's why that's another disadvantage of drip irrigation. And then salt applied with the irrigation water may build up in the root zone. So that is another one thing, that if the water is coming with some salt, the water may build up in the root zone. Another scheme by Indian government, which is Pradhan Mantri Krishi Sinchai Yojana, the target is to provide water to each and every field, har khet ko pani. And the another target is also it having is to improve the water use, more crop per drop. That's what their agenda is, to have more crop or to have a higher yield with less water. And they are very focused on the same. And they are basically providing assistance to the beneficiary under this scheme, under the micro irrigation scheme, and which is 55% for small and marginal farmers and 25% for other farmers. And see, every scheme that is being implemented, it's not only the central government which pays the subsidies. It also sometimes some part is being paid by the central government and rest of the part is being paid by the state government. So similarly in this scheme also, both central and state government pays in the ratio of 60 to 40% for all the states. So 60% is being paid by the central government and 40% is being paid by the state government for under the scheme. So for an example, if 8,000 crores of subsidies is being given, or 8,000 crores of benefits is being given, so 4,800 crores shall be given by the central government, and rest of 3,200 crores shall be given by the state government. So major components of drip irrigation system, we have already talked about it: the pumping set and the filter. So no wonder with the pumping set, one has to create a pressure of somewhat around 2.5 kg per square centimeter to regulate the amount of water which is being supplied. And then filter. One has to filter the water in order to remove the suspended impurities from water. So suspended impurities are basically which may clog, which may clog the pipes. So that's why some suspended impurities must first need to be removed. So that's why a basic filter is being used in so that's why a basic filter is being used, so that the suspended impurities can be further removed from the water, and that water could be used in the could be used directly. Then these are again the component of drip irrigation system. Then the main line and the sub main line, we all know about it. And then the drippers and the emitters. The drippers are basically these small holes, which is basically fitted to a drip irrigation system, which emit water in the form of drops or continuous flows. Dripper function as energy dissipated, reducing the inlet, and then the pressure head in the lateral, which generally ranges from 0.3 to 1.5 atmosphere. Now, the basic benefits to the farmer, it have higher consistent quality yields, huge water savings, no evaporation, no runoff, no waste. It utilize 100% of the land. Drip irrigates uniformly in any topography and soil type. It also works on low pressure. It makes efficient use of fertilizer, no leaching, and because the fertilizer is being spread through these drips, through these emitters, and then it also have a less dependency on weather, greater stability, and a very lower risk. So this is how the drip irrigation system work. If you look at the video on to your left, I'll play it again. So this is how, with the help of drops, every drop, and the water is being spread to every crop. Okay. All right. So these are some of the major pumps used in irrigation. I will talk only about the pumps, that how the states are working to provide energy efficiency to these pumps. One is extracting water from the ground, supplying from nearby canals or irrigation channels. Those are one pumps. And then the last one are which are used directly in the irrigation system. In the right side, you see how the pump work, which is very pretty straightforward. Um, This is how Punjab state government has mandated the energy efficiency into the pumps. They have provided a notification which basically mandate, if you read this, where the cursor is the point number 3, mandatory use of BW 4-star labeled and ISI motor marked motor pump sets, power capacitor, foot reflex valves in agriculture sector. So this is how PSPCL, through a notification through PSERC, Punjab State Energy Regulation Council, they have mandated the use of BW 4-star labeled and ISA motor pump sets. And how they've implemented that, whenever any farmer comes up for a new connection, they will have to make sure that it has to ensure that they are only using minimum BW 4-star labeled and ISI marked motor pump set. So this is how they are implementing. So now they will provide the free electricity, but they will provide it to a 4-star pump. Now, what are the energy savings opportunities in the pump? These are very basic things. Whenever somebody do an energy audit, you may find these kind of stuffs that if the pump is over designed, pump is operated away from their BEP, and then the pump, major issues when we have faced, but we have find is they usually have an oversized pumps. They never monitor the pumps, never control it. They just turn the system on and then they leave. The system is totally wrongly designed. They may sometimes they have a very high size pumps, and then they have pipes, for an example, normal PVC pipes to spread the water, and then they found that the pipe get on off. So these are some of the basic issues which farmer faces. So these are some of the success stories, pump energy efficiency case studies in which they have implemented. This is by Punjab Energy Development Agency in the state of Punjab, in the village Nathu Majra, block Rajpura, district Patiala. They have and the PEDA, Punjab Energy Development Agency, asked Department of Water Supply and Sanitation to identify sites where old and inefficient pumps are being installed, and then so that those pumps could be replaced by Punjab Energy Development Agency. And any agency itself do not install these kind of pumps. They ask any other agency to install these kind of pumps, which would be the installation body. So, for an example, this may be done by ESL, Energy Efficiency Services Limited, which is an ESCO company. So then DWISS identified 19 sites of old inefficient pumps in Rajpura division, and then the proposal was approved by PEDA and replacement of pumps was carried out. So the objective was to replacing old pumps with energy efficient pumps. Financial assistance were provided of somewhat around 30 lakhs, and somewhat around 4,12,681 units of energy was being saved. Similarly, few more demonstration projects in the village Amritsar, revamping of drinking water pumping system. Polytechnic College for Women, Majita Road, Amritsar, one pump system is being installed. Similarly, in SES Nagar, Mohali, they installed 13 submersible motor pump sets. Similarly, another project in Amritsar where the drinking water pumping system was being revamped. And 19 old inefficient pumps, which was by DWSS, which is being identified by DWSS and then implemented the same by PEDA in the year 2020. Now, before we move to the 3-star, 4-star pumps, which is being mandated by the states, first we need to talk about what do we mean by 4-star pump, okay, and where it is written 4-star pump, what star rating basically means. This is a very specific aspect about star rating. So when Bureau of Energy Efficiency came up with this scheme of implementing energy efficiency within the country, they came up with two aspects. One is that every equipment that is being used within the country, it must be energy efficient. So how they implemented that? In order to implement it, they made a specific aspect, okay. And what was that? They mentioned that, okay, they will start with a voluntary program and then they will mandate it, okay. So how they did that? At first they made few equipments voluntary, that okay, these equipments will also come with the star rating. The same manufacturer will go to BWE for asking that, okay, tell us how much energy the system is being consuming, and then they made a standard that, okay, if, for an example, if there is LED light, and if LED light is providing less than 90 lumens per watt, it will be a 3-star LED light. Similarly, if the LED light is providing more than 110 lumens per watt, it would be a 5-star LED light. So based on that standard, they first volunteered the program, and many manufacturers came to them for the same system. Later on, they mandated the same, okay. So now there are somewhat around 10 or 11 equipments which cannot be sold in the market without star rating, okay. So many a time you might see that, okay, if a shopkeeper or if a retailer is selling an AC without star rating, so it is not true. It can be, you can complain against him to the state designated agency that, okay, these ACs are being sold without star rating. Why it is because these equipments are being made mandatory by the central government to being sold with star rating only, and neither the manufacturer can prepare these equipments without star rating, no, nor the retailer can sell the same, okay. So somewhat around 10 to 11 equipments are there which must have a star rating system. Similarly, there are some other systems also which are running within the state. For an example, recently star rating for tires has also been there within in the market. So those equipments basically are running on the voluntary basis. The star rating is there, but it is not mandatory for the retailer to have the star rating or to sell the equipment with star rating. Neither it is mandatory for the manufacturer to take star rating for that equipment. But yes, for the mandatory equipments, for the equipments which are being mandatory, like ACs and a refrigerator is also there, and LED lights are also there, which for which the star rating is mandatory, and one has to take the star rating before selling the same equipment. I mean, the manufacturer has to take the star rating before selling the same to the retailer, and the retailer cannot sell the same without star rating. So this is again the same kind of system. Different states are taking different initiatives. Some says, okay, just for an example, Punjab has done 4-star minimum BW 4-star labeled motor pump sets, and a few more things. Different states do different kind of stuffs for the same. This is another example where the state has taken such kind of initiatives. It mentioned, this is a notification by, in the year came up in 19th March 2015, which mandated use of BW 2-star labeled and ISI marked oil immersed transformer for the state utilities. So this is again how the states mention state implement energy efficiency. All right. So now there are also some myths being associated with the star rating. So it is very important that we all should know about the myths associated with the star rating. we only look at the stars of so we only look at the stars of being provided on the star rated equipment, that okay, if it is 5 star, we consider it as kind of energy efficient system. So it is not true, we have to look beyond. Okay, apart from the star rating, apart from the star, if you look at the label carefully, there will be a lot more things which one should read, must and he should read before purchasing the equipment. Okay, one thing, apart from the star, it also provides you, this is the kind of label that you would see. Apart from the star, today whenever you go home, make sure you see the star rating on your AC, okay, or on LED light, or on anything, wherever you would see star rating, these kind of label, wherever you see, make sure you look at the rest of the things as well. Okay, you would find a lot of things onto that star rating system. For an example, if it is an AC, you would find the appliance type, which is basically kind of split or whatsoever. It would also provide you the brand name. Hold on a second. It would also provide you the brand name. It would also provide you the model year. Now, this is very important. Okay. Many a time, what do retailers do? They purchase the stock for an year. For an example, if next year the budget is being announced and it is being ensured, or people they are skeptical about the aspect that no, in the budget the electronic item would be expensive, or the cost for the same, or the GST slab would be increased for the same. So they purchase a lot of stock within the same year. Now what happens is, the star rating that you are purchasing, for an example, if you are purchasing a 5 star system today, the same system will not be 5 star tomorrow. Okay, why? Because the standard is being increased. So for an example, if today I am saying that yep, so is there any question? Okay, so for example, if today I'm saying that okay, I'm using an LED light, and LED light have is providing 90 lumens per watt, and it is 3 star system. So it may be possible by 2024 there will be new LED lights which would be providing 120 lumens per watt, and by 2024 that 120 lumens per watt will become the standard of 3 star. Okay, and let's say today 90 lumens per watt is 3 star, and 120 lumens per watt is 5 star. Okay, let's say by 2024 new LED lights comes up which provide 150 lumens per watt, and in that case by 2024 this 150 lumens per watt will become 5 star, and 120 lumens per watt will become 3 star. Okay, so today 120 lumens per watt, let's say it is 5 star, but by 2024 if new LED lights comes up, new technology grows up, and 150 lumens per watt light comes up, it will become 5 star, and this 120 lumens per watt will become 3 star. So that's why the system technology increases, the technology increases with time, the technology is becoming more efficient with time, and that's why the star rating also being upgraded with time. All right, so that's why don't only look at the stars only, also look at the year of that star. Okay, many a time and in fact maximum time you would find that the system, the same kind of system, the same 5 star, let us say the same 5 star of any company AC, let's say Blue Star, Hitachi, Daikin, or whatsoever, you are purchasing, somebody is selling the same for 45,000 and somebody is selling the same for 50,000, and why the cost difference is there, make sure you look at the star rating of that system. You would find that one is selling a older AC of 5 star to you. Okay, and another one is selling the newer 5 star rating system to you. So that's why make sure whenever you see the star rating should be new, or at least within the running year on which you are of the year you are purchasing the system. Apart from that, it also provides you the details of the cooling capacity, how much is not only the cooling capacity, what is the input and output, both details the system would provide you on the star rating. Apart from that, if there is anything else, it would provide you like variable speed compressor, if it is a heat pump or anything else, it would provide you that details as well. Okay, so this is one thing. Now, though every um, system or every kind of equipment whichsoever have the BW star rating, they are as per the Indian standards. Okay, but this is one more thing which everybody rating does not, okay, only an energy benchmark. It can only tells you, okay, this could be the energy consumption of the system. This is somewhat the energy consumption of the system, but it does not guarantee the star. Does not guarantee the quality of that system. It may be possible that a BW 3-star system could be more reliable than a BW 5-star system. Okay, so because the system, the star rating only tells you about the energy consumption of the system, it doesn't have to give anything about the quality of the same system. So now these are some of the systems which are being mandatory, and these are some of the systems which are being sorry, these are some of the systems which are being voluntary for star rating. And fortunately or unfortunately, every pumps those are there, or the DG set which are majorly used in the agriculture sector, all comes into the voluntary category of star rating. So that's why states differently have to provide a notification to implement 4-star pump sets into in their state. So that's why the initial notification that I have shown you, it was a BW 4-star pump set which was being implemented by the PSPCL, the Punjab State Power Corporation Limited. Why they have to provide a notification? Why nobody is providing notification for ACs that you have to minimum BW 3-star AC or 4-star AC or minimum BW star rated AC? Because the ACs are under the mandatory category, and one has to, whatsoever AC they purchase, it would have a star rating for sure. But for pump sets, it comes under the voluntary category. So it is not mandatory for the manufacturer to take star rating, neither it is mandatory for the retailers to sell the pump with star rating. It is up to the manufacturer as well as the retailer. It is up to the manufacturer if he wants to go for star rating or not. Similarly, the manufacturer can also sell the same pump without star rating. But how it is being implemented within the state? By the notification through the state bodies that, okay, no new connections would be given if the pump is not BW 4-star rated. So this is how different policies work. This is how states have to find a ways to implement energy efficiency. Now, this is how the parameter on the pump being given. This is again very important. You might have seen this, the star rating kind of nameplate being given on the pump, which shows the number of stars onto the pump. No wonder, the more number of stars, the more energy savings. And then it also provides a specific disclaimer below, which says that it is applicable conditions, on which condition the system would work like this. And then this is very important, a very unique code on every system. Below this, below the BW logo, you would find a unique code. And there is another application by BW Star Label application. You could download that from Play Store as well, or you could go to bwstarlabel.com. It is a website also on which you could apply this unique code and could check if your system is truly 5-star or not. These few things are there. Usually people only check the star rating, that okay, the system is 5-star and we purchase it. One should not do that. A reason is because the star label could be fake as well. So make sure you also use the, or you also use the unique code to check, or at least check the model number, that if the model number is truly 5-star or not. So these few things are very important. And then this system, this in the middle, provides the technical details of the appliance. Now this is important of a star level electrical pump. What details it provides? One is the kind of brand it is, the kind of submersible pump or whatever pump it is, the label period, that to what time the label period is applicable, if it is applicable till 2020 or 2023. Make sure today, whenever you go home of any system that you are using, make sure you check if the label is expired or not. Okay, so and once you would find that, then also check that what is the current label running and to what standard the label is running. So for an example, if you're using an AC, and if your AC says that the label is being expired by 2022, also check what was the standard in 2022, what was the COP or EER of your AC in 2022, and what is the current COP in 2023 for 3-star system. So let's say in 2022 they were mandating for 4 COP or 3.8 COP, they were saying it to be 3-star. So today it may be 4.2 COP for 3 star. So that's why your system also check to where the system is currently standing. It is 2 star or 1 star or whatsoever. So make sure you go and check the same today. So apart from the label period, it also tells you the overall efficiency of the pump set, and then the type, model year, rated power. This rated power is basically the output of the pump. Usually people get confused. People feels that okay, this pump would consume somewhat around 7 HP. If it is 1 HP, it would consume around 740 watt of power, 746 wattage of power. But that's not true. This is the output of the pump. In order to check the input, you have to divide this number by the efficiency of the pump. So if I'm saying that okay, it is 1 HP pump, and with an efficiency of 80%. So in order to check that okay, how much power it would consume, so I would make it 746 divide by zero point 0.8. So this would be the power the system would consume, or in simple terms 1.25 HP power the system would consume. And it would also provide you some more details like the maximum current, what would be the speed in RPM, and number of what would be the head of the pump, and kind of that stuff it would provide you. So this is again the same thing from a manufacturer logo. It may be there diesel driven, diesel engine driven mono pump set for agriculture purpose, and etc etc. These details would be given, and label period again, and kind of the same thing: head, RPM, capacity, impeller size, model number, and kilowatt per HP, and kind of that stuff. Kilowatt HP it would be providing you. So for pump set, the star rating being given on the basis of the performance factor of the pump. Now performance factor, there is a whole derivation how the performance factor is being determined. If require, I could share the details. If required, you could also take the details from the BW Energy Manager book. In the third book, there is a chapter number 5, I guess. It is for pumps. It includes every details of 4 or 5. I'm not sure. It is either chapter 4 or 5, which has all the details from the pumps, that how the performance factor of the pump is being determined. And then for any pump which have um, performance factor of more than 1.40, it will be 5 star. But this is also to be looked into, that the above star rating is only valid from 1st February 2020 to 31st January 2023. After 31st January, this whole system would be revised based on the new technology available in the market. But if there is no new technology available, the 5-star system would yet have 1.40 performance factor. So a small video which would tells you about which products would have a mandatory star rating. It means these products will not be sold in the market without star rating by the retailers. Neither the manufacturer could sell to the retailer without star rating. Okay. So these are the equipment: frost-free refrigerator, fluorescent lamp, and these are the systems which have a voluntary star rating: induction motor, agriculture pump set, ceiling fans, stoves, washing machine, ballast, inverter, diesel generator, chiller, microwave ovens, office equipment, and diesel engines. So these are voluntary appliances. Induction motors, for 5 star it should be IE3 plus plus, above than IE3 basically plus plus, it would be 5 star. 4 star IE3 plus, and less than IE3 plus plus, and so on for 3 star, 2 star, and 1 star. Similarly, for agriculture pump set, we have talked about the performance factor. So above than 1.40, it is 5 star. And again, make sure you check the star rating period, that for what period the system is applicable. Okay. All right. So at last part, now we come on to the energy transition. Okay, that how the system, how the states want to transit their energy, or how the state want to switch the use of electrical energy to renewable energy. So no wonder renewable energy, the major part on which the state could run is biomass. Punjab has a huge potential for the same. Hydro energy, Punjab is also running for the same, but yeah, nearby states, for an example, Kashmir, it has a huge potential for hydro energy. So wonder Himachal is also working on the same. Solar energy is there, wind energy is there, and then geothermal energy. Geothermal does not have uh, different states may find the use of it, but uh, India itself do not have much working on the same.
Energy.
So small video on
Renewable
renewable
energy
energy.
is a term used to describe a group of energy technologies derived from sources that do not deplete or that can be replenished within a human's lifetime. The most common renewable energy sources are solar, which harnesses the sun for energy, wind, which utilizes the motion of wind to create electricity, hydropower, which uses moving water to generate power, biomass, which refers to a large group of technologies that use living or recently living organisms and waste to create energy. Tidal. Tidal uses the rise and fall of the tides to create electricity. Thermal, which uses the internal heat from the earth for energy. Nuclear energy is not considered a renewable energy source. It is considered an alternative energy source. While renewable energy accounts for a minority share of the world's energy supply, it is also the fastest growing energy supply on the planet. Renewable energy is sought after because it is a clean source of energy, meaning that it does not directly produce greenhouse gas emissions or air pollutants. While renewable energy sources are better for the environment, they also face several challenges, the main ones being low efficiencies, high capital costs, and intermittency.
All right. So, few things to be made clear. Nuclear energy, they do not consider the same into renewable energy, and also the big hydro plants. Recently, there is news about the Joshimat, which is being sunken down, um, and many people have a direct claims of bigger hydro plants being installed nearby it. So, bigger hydros are nowhere considered under the renewable energy system. The small hydro plants are being the part of renewable energy system. So, this is very important to understand. The bigger hydro above a particular range are nowhere being considered as a renewable energy, because renewable energy does not mean that these systems do not directly produce the greenhouse gas emission, or do not directly have the greenhouse gas emission. Instead, these systems must not have an bigger impact on the environment, but the bigger hydro, they have an impact on the biodiversity of the nearby areas, and that's why the bigger hydro are not considered under renewable system. So these are some of the renewable energy initiatives taken by the state of Punjab. Similarly, different states have taken different initiatives, like small hydel projects on canal falls, biomass or agro residue based power projects, cogeneration power project in sugar mills, solar photovoltaic based technologies, and solar thermal systems and biogas development program on which the state of Punjab has worked. So similarly, Punjab has a mission of 2,500 megawatt of energy from renewable sources by 2022. NRSE policy launched in 2012, which target renewable source of energy 15% of the total installed power capacity by 2022. Then, in order to harness the renewable energy properly, they provided a scheme, the state government, and no wonder, not this is not only the scheme under Punjab. Different states are using the same scheme. Rajasthan is using the same. Haryana is also using the same, which is basically the net metering. Under net metering, what happens is, if you are installing a solar power plant at your rooftop, you would provide electricity to the grid back. If there is surplus electricity, the solar would generate the electricity, let's say in winter, and you are not using the same electricity will go to the grid. So you will have a bi-directional meter, and the meter would also count the energy that you have supplied to the grid. Okay, and then the electricity bill that you will get, you will have a total reduction in the total amount of the total electricity that you are using. Okay, so let us say if you have used 600 units of electricity, and you have applied you have given back to the grid for around 400 units of electricity, so the electricity bill that you will get is only of 200 units of electricity. So that's what the net metering policy is. Nowadays, they are closing the net metering scheme. Instead, there is another scheme named as gross metering. What happens in the case of gross meter? instead of selling the same electricity to grid, here also you sell the same electricity to the grid. The government will not deduct the total units of your account. So, for an example, initially you have consumed 600 units and you have sold 400 units to the government or to the grid. Your total energy bill is directly being reduced to 200 units. But here, if the government is giving you 600 units at a cost of 10 rupees, they will purchase the back unit, which is around 400 units that you are selling to the government. They will purchase it at a lower cost. So let us say if they are purchasing it at 3 rupees, okay. So if your total bill is 600 into 10, which is around 6,000, and 300 units or 400 units, let us say you have given back to the grid, so they will purchase it, let us say it is at a cost of 3 rupees, let us say. So it would reduce your total bills by 1200. So 400 into 3, it is around 1200. So your total bill would be 600 minus 12, which is around 4800 you have to pay to the utility company. So that's what termed as gross metering. Okay. So current RE capacity in the state is somewhat around 12%. So this is the new renewable resource policy 2012 initiatives. 100% electricity duty exemption on power consumed during construction of NRSC project. Then panchayat land can be provided on lease for setting up of NRSC project. Wheeling of RE power at a uniform charge of 2% of the energy fed to the grid under intrastate open access. Open access basically means that, for an example, if I'm having a huge hotel in Delhi and I do not have enough space in my hotel to install a renewable energy plant, so what I can do is I could purchase a land nearby Delhi, which may be either in Rajasthan or maybe in Gurgaon or Noida or maybe in Faridabad. I could buy a land there and could install a big solar plant. Let's say I'm installing 1 megawatt of solar plant there, and then I could use the same electricity that is being generated in Faridabad. I could use the same here in Delhi. That's termed as intrastate open access. And that in order to use the same, I have to provide it some wheeling and distribution and transmission charges to the grid, to the utility company. That's different charges, and that's why under NRSA policy, if you are doing the same, the wheeling of RE power is only being charged at 2% of the energy fed to the grid. So that's one thing. And then 100% exemption on pollution and environmental clearance on solar project. It is being totally exempted. And then 100% stamp duty exemption, both on land purchase, lease, and change of land use charges has also been exempted. Another solar energy.
Sir, you have given the example of hotel. So, hotel in Delhi. So, can we do it for residential complexes also? Or
Yes, you can do that, but that would be a very expensive system because the
yeah,
wheeling
yeah.
charges are also there. And for hotels, they usually have a reduced demand. Okay, if it's say, let us say, if it is 500 rooms hotel, most of the times 250 rooms would be filled. So if you go above your maximum demand, there are also some more clauses added to this open access system. Different states are working on it. Bengal has done good into that part. I have worked on a project in West Bengal. It's the same kind of hotel was there, and in that they have used the same. They have installed a plant somewhere, I guess in Assam or somewhere, and they are using the same electricity through the wheeling charges. Punjab is yet running on the same, but the same open access is not being directly implemented in Punjab. In Punjab, you can work on if you are installing the plant within Punjab only. So, for example, if you are having a hotel in Amritsar and you are installing the plant somewhere in, let's say, Batinda, so that you can work on open access. Okay. For residential also you can do, but it would be a very small system, which I won't say would be very effective or very efficient for you. I mean,
Yeah.
it would be cost expensive. Okay.
Yes, sir. Okay. Thank you. Thank you, sir.
For renewable system, if I say, for usually people consider renewable with solar only. For residential, no wonder you won't be um, going with such amount of installing a wind energy system. So most probably you would be going with the solar plant system only. So solar plant, somewhat around 1 kilowatt of solar system generates somewhat around 4 to 4.5 units. So let us say 5 units. Nowadays the systems are becoming efficient, the panels are becoming efficient. So somewhat around 5 or 5.5 units they would generate in a day. Okay. So how much we consume in our household? Maybe 20 units per day, that's maximum if you are using ACs directly. One AC
Neeraj,
for running for 1 hour of 1 ton somewhat consume around 1 unit. Yes.
Neeraj, can we just wind
Yes,
up
am I
in
audible?
2-3 minutes if possible? Yeah.
Hello.
Yeah, Neeraj, can you
Yes.
just wind up? So we have next session
Yes,
also
yes,
lined
yes.
up actually. Yeah,
Yes,
thank you.
yes.
Thank you so much.
It's just 10 minutes left. Yes. Okay.
Right, right. Okay.
So similarly, the solar systems they just generate 5 units per day if you have a 1 kilowatt system. So that's why for residential it won't be that effective. These are some of the solar energy highlights in the state of Punjab. Punjab has set a target of deploying 3,000 megawatt of solar projects by 2030. That's what their targets are. And last thing for the agriculture sector, there is one major scheme is being running within the state, which is basically by Ministry of New and Renewable Energy, solar water pumping scheme, and which is towards energy transition of providing solar energy for the pumps. Okay, so government of Punjab has provided 10% subsidy, and a total of 1850 pumps were being installed long back from 2001, 2002, 2004. Later on, now under National Solar Mission, PED has installed 2970 pumps of 3 and 5 HP during the year 2018-19 and 2019-20. The scheme name is PM Kusum, Pradhan Mantri Krishi Uthan Suraksha Evam Mahabhiyan scheme, under which, if you see at the left, these are the pump capacity 3, 5, 7.5, and 10 HP. And this is the total cost of the pump, 1,58,791 for 3 HP, and similarly 10 HP pumps is somewhere around 4,39,000. And for which how much the farmers have to pay. These are the surface solar pumps, and in the right is the submersible solar pumps. So here, if you see the farmers in the SC category, the farmer only has to pay somewhat around 31,000, and similarly the general category, the farmer have to pay somewhat around 63,000 for 3 HP pump. So rest is being subsidized. So if farmer share is 40%, and if the farmer is from SC category, the share is only 20%, and rest 80% the government. In the general category, 60% would the government would pay. This is the PM Kusum scheme, under which PEDA has done a wonderful work, and similarly Hareda has also, in state of Haryana, they have also implemented or installed a lot of pumps. So it has basically three components: solar power plants of 500 kilowatt to 200 megawatt capacity being installed. Under component B, standalone off-grid solar pumps of up to 7.5 HP capacity, and under component C, grid-connected agriculture pumps of 7.5 HP are being installed. So that's under the PM Kusum scheme. Every state is running directly on the scheme. The only challenge the farmers are facing with this scheme is once the pump is being installed. Let us say if the state has installed 5 HP pump, let's say I am a farmer and I have asked the state and I have applied for the same scheme and I have been selected, and then a pump of, let us say, 7.5 HP is being installed at my field. Later on, if the water level drops down, the deepening of the borewell, the farmer has to do it at his own cost. And when the farmer will pay his own cost, he would definitely go for a normal pump instead of a solar pump. So that's what the challenges the farmers are facing, that once the water level drops down, the deepening of the borewell has to be done by the farmer at his own cost. So so this is the a small last video on PM Kusum, and then we'll close the session for today.
हमारे जो किसान भाई या फार्मर्स हैं इंडिया के, उनके लिए है स्पेशली बनाई गई है, और फेम 2 से बड़ी स्कीम है। यहाँ पर टोटल अगले 10 साल के लिए 34,422 करोड़ रुपए रखा गया। क्या है ये स्कीम, थोड़ा सा आपको आइडिया देता हूँ, बाकी हम आगे चलकर बात करेंगे। इसमें जितने भी वाटर पंप्स हैं, हम देखते हैं जो भी जितने खेती के लिए पानी निकालते हैं जमीन से, उसके लिए पंप लगते हैं, चाहे वो बिजली से चल रहा हो चाहे डीजल बेस्ड हो, तो उसको आस्ते आस्ते गवर्नमेंट ऑफ इंडिया चाहती है कि उसको खत्म करके टोटली जो रिन्यूएबल एनर्जी पर उनको जो इलेक्ट्रिसिटी चाहिए वो रिन्यूएबल एनर्जी से ही पैदा की जाए। मींस जहाँ ज्यादा सोलर एनर्जी की बात हो रही है, अब और रिन्यूएबल पार्ट भी आप यूज कर सकते हो, बट ज्यादा फोकस सोलर एनर्जी पर रहेगा। मींस आप गवर्नमेंट ऑफ इंडिया इसके लिए बकायदा बहुत बड़ी सब्सिडी भी दे रही है आपको। फॉर एग्जाम्पल, आपको जो फार्मर्स का जो अपना खर्चा रहेगा इनिशियल, वो सिर्फ उनको जितना कॉस्ट उसकी बनेगी उसका 10% उन्हें अपनी तरफ से देना है। 60% सब्सिडी इस स्कीम के लिए गवर्नमेंट अपनी जेब से देगी, और 30% आपको बड़े सस्ते में, बहुत सस्ते में लोन जो कोऑपरेटिव सोसाइटी है, जो और बैंक है, आपको प्रोवाइड करेंगे। और इस स्कीम का नाम है कुसुम, इसका फुल फॉर्म है किसान ऊर्जा सुरक्षा एवं उत्थान महाअभियान। बिल्कुल 10 साल के लिए इसको बनाया गया। पायलट प्रोजेक्ट पर ही बिल्कुल 15,000+ करोड़ रुपए प्लानिंग या खर्चने की, ओवरऑल 34,422 करोड़ खर्चा रहेगा। बाकी सर आप पूरा।
All right, so with this